So we have so far go through introduction of the database system, as well as the relational database system. We discussed the relational model, discussed how we can map how we will perceive the world as a bunch of relations, and then get the attribute of the relations and map them into tables. Right, this is the a two-step process. The first step of mapping real-world instances into relations is called logical design. And the second step of mapping relation into physical table is called physical modeling, physical mapping. And we already see how physical mappings can be done, how tables can be created. Now, let's talk about how a logical design can be done now. So relational database in its simplest form can have only one table, one two-dimensional table, right? If I want to create, for example, a grading sheet for our course, I may just pull up my Excel and open up one tab and input the informations for each student ID, student name, attendance record 1, 2, 3, assignment 1, 2, 3, etc. And final score, final exam score, midterm exam score, project score, and calculates, then use the total score column to calculate the total score and map it into a final grade. So this, in most cases, I mean, in the simplest cases, this one table, the relational database actually work. It is a two-dimensional table. It is a relation. Or sometimes when like my wife is hosting a baby shower for some of her friend, then she's going to use the Excel spreadsheet, register the names of attendees, and then what gift each person will bring in. So this Excel spreadsheet also serves a purpose, right? These are all possible, but this is possible. However, once your data set becomes complex, you can't keep it only in one spreadsheet anymore. You have to have a multiple entity. You have to have a multiple relations. Then this is when things get interesting, because this can really get complex. In order to resolve this complexity, we have to use a certain modeling technology in order to break the real-world data set, the real-world example, real-world question, into smaller, resolvable, manageable data set or data model. The most popular logical design model is an entity relationship model, or sometimes we call it ER model. This ER model divides relations into two categories, entity and the relationship. It provides a systematical way of mapping real-world objects into entity or relationship. So basically what it does is for each thing in the real world, this entity relationship model will have a way to look at it and identify whether this is an entity or a relationship. Then once we know it's an entity or relationship, then we also need to define how they interact with each other. Because like we said, any model, any complex question involve multiple parties. And it's not only the parties that matter, it's also the interaction between these matters. So an ER model will help us identify these things, these parties, and identify how they interact with each other. And then based on this information, we will come up with a list of relations in this data set. That's how we do the logical model. So what is the entity? Basically, entity is anything you describe with a noun. It's any real things in the world. For example, student is a people or a course or instructor, right? A student have an ID, have a name. This is a thing. Student is a person, or a course is a thing. That you have an ID, course ID, course name, course department, and also like a classroom. When we were teaching in person, we talk about this classroom and that building. These are all entities. Anything you can describe with a noun is an entity. Entity is by itself a relation. So it has everything a relation will have. You can describe it with shorthand representation, and it also have attribute definitions. So for example, for student, the entity student, it is also a relation. It's a relation student. What you are going to write is a name, the relation name or entity name, student, with a parenthesis, with all the attribute of that entity or that relation inside, with the primary key underscored. So that's a student, ID with underscore, name, DOB, date of birth, address, within parentheses. That's how you describe a entity. So entity is relatively simple. How about relationship? Relationship basically is the association or interaction between entities. Usually you can describe this relationship with a verb. It's a verb between two entities. Like a student and a course, student will register a course, right? Students register courses. This register is a verb. So you will create a relationship, registration, the noun form of register. Registration is the relationship's name. And remember, relationship is also a relation. So relationship also have all the entities, all the attributes it has. Because relationship is the interaction of two entities, each relationship instance is defined by the interaction between two instances. For example, student Tom, registered DS530. Student Mary, registered DS610. Each is a registration. It will be a Tom with DS530, Mary with DS610. For this relationship tuple, this relationship basically is the combination of one tuple from one entity and one tuple from another entity. So the way you look at the relationship is a combination of two entities. When you describe this relationship, you start normally as the relationship name or relation name with parentheses. And inside the parentheses, you will have attributes from both tables, from both entities. That's when you see that you have a student ID name, DOB address, and the course ID name, department location, all inside because they all can be a part of this relationship. Now, relationships can also have their own attribute, not only the entity's attribute. For example, once you register a course, you will have a status. It will be registered. Then once the course started, it will be like ongoing, some status like ongoing. Once you finish, you will have a pass, or hopefully only pass. Then also, once you finish, you also have a relationship, like a registration grade. What grade do you get from this registration session? And maybe you can even add, like if you have a final exam and a midterm exam, this can also be a part of this particular registration session, right? So these are attributes that only belongs to a relationship. It does not belong to any entity. Or I should say it belongs to the interaction of that entity, which is the relationship. So these attributes naturally goes to the definition of relationship. Now, when you put two entities together, so far we have been adding all the attributes of both entities into a relationship, but apparently not all of them are required. In the minimum, you will need the primary key of both entities in the relationship definition, because like we said, Relationship is the interaction between one instance of one entity and one instance of another entity. So in order to identify this relationship, you have to identify both instances of both entities. So in this case, you need to have the primary key of the instance in one entity and the primary key of instance in another entity. For example, for registration, at minimum, you will need student ID and the course ID. That's when you know which student takes which course. Now, also, you will need to have all the relationship attributes like grade, like status, all these. This is the minimum requirement for relationship definition. We also have other attributes from the entities, right? Student name, course name. Do you need them in the relationship? This is actually a question we call normalization. We will discuss this very soon in today's course. But at this point, let's say we start with the minimum. In order to have the registration definition, the relationship definition, you will need to have a primary key of both entities, as well as the relationship's own attributes. This is the minimum you will need. Whether you want to add more attributes from the entities is a question, is a decision that can bring both pros and cons. And we will discuss these pros and cons in later session. Okay, so now we have the relationship. Let's talk about the cardinality. Cardinality basically is the count of instances with each instance can interact with. For example, a student in the student course relationship, a student can have can register multiple courses, and each course can have multiple students, right? And if you look from a relation side, it means an instance of a student can interact with multiple instances in the course side. And an instance in the course side can interact with multiple instances on the student side. This is what we call many-to-many. And sometimes a student, one instance in one entity can only interact with one instance on the other entity. For example, department course. Each department can have multiple courses, right? But each course only belongs to one department. So far, I have yet to see any courses that belongs to multiple departments. So in this case, we call it one-to-many. One department can have multiple courses, and each course only have one department. This is one-to-many. If you draw a relationship picture, then you will see that one department will have many branches going through to the courses. And one step further, from one-to-many, we have one-to-one. For example, state and the state capital. State and state capital, each state have only one capital, and each capital belongs to only one state. So this is the one-to-one. One-to-one is usually rare. Actually, the problem with state, the problem with the state and the state capital, the problem with one-to-one is in reality, this is rare, and it's hard to tell whether something is really one-to-one or not. We know state and state capital are one-to-one because we are all like grown-ups, graduate students. We have been, through our lifetime, we already learned and remembered all 50 states and their capitals. So it's an we have already done an exhaustive search and identified that all possibilities. And based on all these possible of combination, we already know it's a one-to-one. But what about country and the country capital? without any Googling, I can tell you there are some countries with multiple capitals. I think there's one country, I forgot the name, has 3 capitals, one for each branch of the government. I think the legislation, executive, and what's the other? And the legal, yeah, the one capital for each. So normally people will think country and the country capital is 1-to-1, right? But the reality is it's not. How do you identify? How do you know that? It is actually the table designer, the data modelers, and the data scientists' responsibility that you need to perform business research and data discovery. It's your job to research the data and identify what's the type of a relationship. So there's not really no easy way. If you think something is going to be 1-to-1, for example, but later on it proves that you are wrong, then you have to adjust your model. I myself, I used to design some data model, and I thought customer and the social security number is a 1-to-1 relationship, but it turned out it's not. Some people, some foreign nationals actually, because they enter United States multiple times at a different time, so they have a multiple social security number. So that's a lesson I learned, that don't assume. You have to do some data research, and also be prepared to change your model if anything happens. And once we talk about cardinality, basically what is cardinality? Cardinality is the number of instances on the other side that any instance will interact, right? For student, if a student can register multiple courses. Now, we already said it's a 1-to-1, one-to-many, many-to-many. This is the maximum cardinality you can have. A course can have a multiple, can have many students. A student can register many courses. A department can have many courses. A course can have only up to one department. This is the maximum cardinality. How about the minimum cardinality? For example, in our example department and the course, we already know that the maximum a department can have, a course can have, department can have multiple courses, but each department should have at least one course. We have not seen any department that does not have any courses, right? And at the same time, each course must belong to at least one, at the most one department. There's no course belonging to 2 departments. There's no course does not belong to any department. Each course belongs to one and only one department. So the way we describe it is 1-1-to-many, right? So department is always one. For course, there's always one department. For department, there's always one-to-many courses. And then another example is a customer and the cable TV company. So a cable TV company should have one customer, right? And it can have multiple customers too. But the customer may not have a cable TV subscription. Some people just haven't signed up to cable TV, but most people have one. And usually I think people only have one sign up. If you sign up Verizon, you're not going to sign up Comcast or vice versa. So in this case, the cardinality of company is 0-1. That's how we describe it. You can have 0 company or 1 company. You should have 1 to up to M customer. And similarly, there's a limit, right? And let's say example for a student and a course. Each student can sign up multi-course or none. So maybe you don't need to sign up courses for one semester. That's allowed, I believe. But so in this case, each student must have course 0 to M. Can have a 0 course or have multiple course. Now how about each student must sign up at least one course? It will be 1 to many. So each student must have a one course. Or if you actually have a determined upper limit, you can write this down instead of M. You can just write 1 to 5. That means you have to sign up at least 1 and most 5 courses. This is how we express cardinality. And finally, there's this distinction between relation and the relationship. Unfortunately, the name is similar and is used in the same course against the same thing, the data set, but the meaning is different. I understand it can be really confusing. Relationship is a type of relation, but the relation has we have two different types of relations, entity and the relationship, right? Entity relationship model is an enhanced version of a relational model and the most popular one. Relationship is a type of relation. Relation is something that more of a mathematical background and utilized in a more theoretical side, whereas entity relationship model or ER model is used more on logical mapping, logical modeling, where we map real world things into a logical model, into relations. Hope that reduced some of the confusions.